Hey guys, we are jumping to 9.4. We're going to talk about trig ratios, one of which is tangent. Okay? Here's the skinny on the next two class periods. There are three trig, which is trig on a tree, the study of triangles. There are three trig ratios. That's it. Remember, a ratio is a comparison of two numbers. A ratio is just a number compared to another number. We write them as fractions. You could write them with a colon. You could write the word two. There are three trig ratios. They are sine, cosine, and tangent. If you look on your calculator, you'll see a button that says SIN. That is the abbreviation for sine. We never call it sin, we call it sine. Don't say sin. Okay? Cos. We're not going to say cos either. COS, the word is cosine. And then tangent, the abbreviation is TAN. It's also on your calculator as TAN. Okay, today we're going to do tangent, and then sine and cosine ratios we will learn next class. Okay, so the other thing we have to talk about real quick is, we're going to call this triangle cat. Opposite, when I say opposite side, what do I mean? You have done this, but you did it first semester, so it should pick up easy this time. Okay, if I ask, okay, first, which are my legs, right? Remember, the box points to the legs. I'm always going to write the word or the letters in the middle of it, so it helps me see this is my leg. This is my leg. Okay, now I'm going to ask you a couple questions. Which leg is opposite to angle A? Which leg is opposite to angle A? When I do these, okay, opposite, think the word across. Everybody that I've worked with today can do across, even if they can't do opposite. Okay, I'm grabbing a pencil, sorry. Should have had it already. Okay, when I do opposite of A, I'm going to circle my angle, draw an arrow from the angle to the middle of the opposite side. That is my opposite. Okay? So from angle A, the opposite would be side CT. Okay? CT. Now, if I ask you which leg is opposite to angle C. Okay, let's look at angle C. So instead of A, this eraser's not real good, sorry. It's what I got with me right now. It's a junky eraser. Okay, I'm going to circle the angle. I'm looking at angle C. Okay, here's angle C. Which leg is opposite? You're going to draw the line, go to the middle. Across is opposite. So opposite to angle C, start to end. It's either segment TA or segment AT. Both are the same thing. Okay, those are opposites. If I ask you which leg is, let's go from this one, C. Which leg is adjacent to angle C? Okay, I've only got two legs. My opposite leg is side TA, which leaves only one left. If this is my opposite leg here, that means this has to be my adjacent leg. Adjacent. I'm going to abbreviate it, okay? So they're either opposite legs or adjacent legs. That's all we're working with today, and you'll see why in a second, okay? So if it's not opposite, it has to be adjacent. Adjacent means next to, okay? So this side is adjacent to angle C. It's one of the sides of the angles. Okay, now we're going to talk about tangent. When we do sine, cosine, and tangent, we're always going to refer to one of the acute angles of the triangle. Okay? So if this is triangle dog, I ask you what are the acute angles. I know angle O is a right angle. And then that means angle D and G are acute angles. They measure less than 90. Right? It's a cute little angle. So everything that we're doing will be referred to by acute angles. Okay, let's talk right now. What is the tangent? What does this ratio mean? First, we don't say tan A. This is tangent of angle A. This is always an angle. Angle, always. And it's always going to be an acute angle. Cute little angle. Angle A will always, whatever is here, this angle will always be an acute angle. So when we talk about tangents, it's going to be for an acute angle in the right triangle. Okay? Okay, here's what it is. The tangent of an angle, in this case we're saying tangent of angle A, equals the opposite leg to angle A. Okay? Oops. It's the length of the leg that is opposite to angle A. The length of the leg, the opposite leg to angle A. I'm usually just going to say OL, opposite leg. It's the length of the leg that's opposite to angle A. Okay, here, this one is going to be the length of the adjacent leg to angle A. So we're working with adjacent legs and opposite legs, the lengths. Opposite will always be on top, adjacent will always be in the denominator on bottom. That's how tangent is defined. Okay, the tangent of an angle equals length of the opposite leg divided by the length of the adjacent leg. And this here will always be the measure of an angle. Always the measure of an angle. Okay, let's do a problem. We're going to call this triangle DOG. Sometime I'll get creative and do something different. The length from D to O is 28. The length from O to G is 45. The length from D to G is 53. And I'm asking you, what is the tangent of angle G? The tangent of angle G. Okay? So I'm going to circle my angle. Circle the angle. Okay? We're going to label opposite leg and adjacent leg. Oh my gosh. You guys, label opposite leg and adjacent leg. Okay? And then, so from G, we're going straight across, right? So this is my opposite leg. So that means 45 is my adjacent leg. Number 3, write the tangent ratio. We'll say the tangent equation, tangent formula, okay? So tangent of G equals opposite leg over adjacent leg. And that's all we're doing right now. So what is the tangent of angle G? My opposite leg is 28. My adjacent leg is 45. That's all I do. And then if I want to write it as a decimal, I just divide 28 divided by 45. Okay, I am going to jump down to number 4 on this front page. Okay, let's go here. Okay, tangent of C. I'm going to circle my C. So tangent of C equals opposite leg, adjacent leg. That's what I know tangent means. It's always opposite over adjacent. Always. That's how it's defined. So from C, what is opposite leg? Remember, the box points to the leg. So this is a leg, and this is a leg. C goes straight across. This one's your opposite leg. That's your OL. You could just write OL. So that means this one is your adjacent leg. Okay? So I'm going to go ahead and fill it in. Tangent of C equals 24 is my opposite. My adjacent is 10. That's all I want. And then divide 24 by 10, 2.4. Okay? So all this is correct. It's all you have to do. Okay, so when I do, now that's how all of these are. The big thing is pay attention to where the right angle is located. You always have to pay attention because everything depends on where that right angle is. That determines which are your legs. And then you determine opposite leg, adjacent leg. Okay, I'm going to go to tangent of S. I'm going to put tangent of R down here because it just won't fit, okay? So let's look at S first. So I'm circling, right? I'm going to circle the angle. So I'm circling S. That's where my angle is. I'm going to label opposite leg, adjacent leg, where the box points to the legs. So this is a leg, and this one's a leg, right? I'm going to go opposite. So that's across. Sometimes you guys think, when you think opposite, right? Opposite, I'll write it up here. Opposite. Some kids are doing a lot better using the word across. But I'm always going to say opposite, and I'll say across too, but when I write it, it's always going to be opposite adjacent. Across works with opposite. Okay, so this one's my opposite leg. That means this one has to be my adjacent leg. So the tangent of S is opposite, right, over adjacent, which is 80 over 18. You can divide that yourself. So I'm done with the tangent of S. So let's do the tangent of R. So I'm going to erase this. Okay? We're going to circle instead the R, right? So now how I label them is different, right? What's opposite of R? It's going to be total, a reciprocal. We're flipping the fraction. So from R, the opposite leg will be here. Now this 18 is the opposite leg, so that means 80 is my adjacent leg. So from R, it's going to be 18 over 80. Notice S was 80 over 18. The angle, this is called a complementary angle. If this one's 90, right, 180 minus 90, I have 90 left. So these two angles are going to add up to be 90. Whenever I find the angle of its complement, the other angle, the tangent ratio of the other angle, it's always going to be the reciprocal. Instead of 80 over 18, it's 18 over 80. Okay, just showing you that. So that takes care of the first page. Now, I want to go to another type of problem, okay? I'm going to call this again dog. The length from D to O is X. The length from O to G is 15. This time, I'm going to put the measure of the angle. When I put a number on the side, it refers to the length from the nearest endpoint to nearest endpoint. 15 refers to the length from the nearest endpoint to the nearest endpoint. If I write a number inside of here with a little degree, okay, that's referring to the measure of angle C. How much these two rays are opened is 27 degrees. Okay, this is 27 degrees. I'm not going to include the degree in my work though, because it's too messy. Okay, so here's going to be my steps. First thing I'm going to do is circle the angle and the measure. Some of you guys, this is called scaffolding when I give you steps. Some of you will not need all this detail, and some of you will. Number 2, label opposite leg and adjacent leg. Okay, so I'm going to go straight across, opposite leg. Make sure you can do that. If you can't do that, you're in trouble. Remember, the box points to the legs. This is adjacent leg. Okay? So I'm going to write the formula and fill it in. Okay? So I'm going to put tangent of G, right, equals opposite leg over adjacent leg. So let's just start filling everything in. Tangent of this G means the measurement of the angle. Tangent of 27 degrees equals the length of your opposite leg, x, over the length of your adjacent leg, 15. Now we have to solve for x. So I want to isolate my x. Right now, the x is on the right side of the equation, right? It's on the right side with this 15. I have to get rid of the 15. So I'm going to go times 15. I'm not going to write times 15 after the 27. I'm going to write it before the word tangent, and you'll see why in a second. I'm going to write it first. So that gives me x equals 15 times the tangent of 27. Okay, get my calculator. Did I get it cleared on? Okay, clear. So, let's go 15, right, times, I hit the word tan. See how I get this parentheses? If I were to write 27 and times 15 inside the parentheses, it messes up here. It'll mess up my angle measurement. Here, I only put the angle measurement. I'm only going to put 27. So you can close the parentheses, but you don't have to. But notice I put 15 first, times what the tangent of this angle is. My angle is 27. Okay, hit equals. I get 7.64. Let's think about this. This is 27 degrees, right? 90 minus 27. So this angle up here is 63. You don't have to do this. I'm just helping you think through this. 27, opposite of 27, the length is 7.64. Opposite of a 63 degree angle, the length is 15. That makes sense to me. Okay? So that's how you do that problem. That will take care of the back. So we're going to jump over and do on the back side. I want to do one of these types of problems that's the algebra is more difficult. Okay? So we're going to circle the angle that has the measurement. We're going to circle that together. We're going to label opposite leg, adjacent leg, and then we're going to write our equation. Okay? Let's flip it over. So number one, first thing that you need to do is circle the angle. I don't have a letter here. I'm just going to circle my angle. I got it. From that angle, we're going to label opposite leg and adjacent leg. The box points to the two legs, so I know this side is a leg. I know this side is a leg. This one, go across from the 32, so this one is my opposite leg, which means this side here has to be my adjacent leg. I'm going to write my formula. I'm going to write up high because I know where we're going. The tangent of the angle, right, equals the opposite leg over the adjacent leg. So we're the tangent of the angle is 32 degrees. So the tangent of 32, do not put the degree symbol in there, equals the length of the opposite leg over the length of the adjacent leg. Now look what we have. This one is awful, okay? We have x in the denominator. I have to have x in the numerator. I have to get it to the top, okay? I cannot say, well, let's divide by 11 to get rid of that. No, the x is down, so I have to get rid of it. I have to move it up. So I'm going to go times x times x. These will cancel. I'm going to rewrite it so it's pretty. X times the tangent of 32 equals 11. Now I look at this, is the x by itself on the left side of the equation? And it is not. I have to get rid of tangent 32. To get rid of tangent 32, I do the opposite of multiply, which is divide. So x equals 11 divided by the tangent of 32. Now sometimes kids are messing this up. You always read from the top down. 11 divided by the tangent of 32. Okay, let's clear it. Let's try it, right? 11 divide by tangent 32. You could close the parentheses or not. It doesn't matter. Execute. And I've got x equals 17.6. Okay? Let's look at this. This side right here, 17.6 long. This is 11. It's the opposite of 32. 180 minus 90 minus 32 would be 58. Would it make sense if opposite of 32 is 11 and opposite of 58 degrees is 17? Yeah, that makes sense. Okay, so I've done two of these. Pay attention. If the x is on the bottom, it's more work. If the x is in the numerator, as it was on this one, all you got to do is get rid of this, multiply by 15. Okay, get rid of the denominator. In class, I only did this section first. The angle of elevation I did with the next lesson, but I'm going to do it right now. Okay, if I am on an ocean and I've got my boat and I look up to the top of a cliff, the angle of elevation is when I'm looking, it's from the horizon to looking up. This is my angle of elevation, okay? From the horizontal to the upward line of sight, okay? Okay, angle of elevation is an angle formed by the horizontal line, with the upward line of sight. We're looking up, okay, right here. This is always right here. From my horizontal to my, I'm looking up to the top, up to the top, up, up. This is my angle. That's where it always goes. It does not go from the vertical to looking down, right? It starts down here, looking up. Okay, so let's do a problem real quick. Okay, I'll write this. This is my horizontal line, right? And this is my upward line of sight. The big thing is, like if my eyeball was down here, right? Here's my eyeball. I'm looking up, 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 up. I should have drawn the dot looking up, okay? Okay, so here we go. You're standing, here's you. Okay, we're standing from a tree. Here's a tree, a building, I don't care, whatever it is. Okay. We're going to go from the ground to looking up, this angle of elevation to the top of the tree. This angle right here, let's make this 35 degrees. That's my angle of elevation. Okay? And let's say you're standing 100 feet from the base of the tree. So my angle of elevation is 35 degrees, okay? And you're standing 100 feet from the base of the tree. Okay? The question is, how tall is the tree? I should have made that a lot bigger. Okay? So I'm trying to find this, the H. How tall is a tree? So and we made this like a sequoia tree. I don't know how big General Sherman is. Okay, but this is going to be a tall tree. So I'm going to call this over here. Don't put height at the top. Okay, don't put your H or your X up here. Write it right in the middle so you can see it. And we're going to do tangent. This is still from 35, opposite leg, adjacent leg. We're measuring the height with a right angle. So we're going to go tangent of 35 degrees equals my height, and I'm standing 100 feet away. This is my 100. Okay? That's how you do that. And I have 2 story problems on the back with that. That's it. We'll do those in class. I hope this is helpful. There you go. See you later in class. Bye.